Wouldn't it be amazing to record your experiences and share them with others? You would say, I do that all the time. I just use my cell phone or action camera to video record my adventures and then post them on social media. You're right, but I would like to show you a new way that not only allows people to see what your camera saw, but allows them to experience the place you were in 3D and empowers them to explore the area as they desire. First, let's talk about capturing the image data. Way back in 2021, just after purchasing my first real drone, I took it out to a local park in upstate New York to record a simple casual walk. I was experimenting with the features of my Skydio 2 drone and set it to orbit me while I slowly walked on a trail through the park. The drone autonomously flew itself, visually tracking me and possibly using the GPS signal from the beacon device as needed that I carried in my pocket. In flight, the drone snapped a photo every 2 seconds, capturing 281 images in total. Tracking worked really well, though the drone did get stuck a couple of times. It didn't crash at all, but it halted its travel and hovered in place occasionally when it flew close to the trees. When this happened, I just restarted the orbiting and redid that section of my walk. While I used an orbiting tracking drone for time-efficient photo capture, imagery could easily be captured with video using any camera. If I were to use an action camera for this, I would walk the path and multiple tracks parallel to the path, pointing the camera in different directions to record anything I could have seen looking in any direction from the path itself. Video frames could later be extracted from the video to provide the photos for creating the Gaussian Splat model. So what did I originally do with that data? I created a 3D photogrammetry model from the photos and then a virtual fly-through video of that model. I posted it on YouTube and provided a link that interested viewers could use to download the photos to process them as they saw fit. I've included that link in the description along with several other resources I'll mention throughout this video. The model was quite impressive given the sparsely captured oblique photos of the terrain and my limited experience with 3D photogrammetry software at that time. For reference, I used the standard edition of Agisoft Metashape to create that model. Well, since 2021 technology has improved. Using it, I've reprocessed this data in a way that allows you to walk around this park either on a computer or in VR. Creating this interactive environment involved 2 steps. First, a Gaussian Splat model was created from the photos. Second, that model was uploaded to a website named Arrival Space. Arrival Space is a web-based service that has created a capability to view 3D content, including Gaussian Splats, in a web browser. The overall interface feels like a game environment, and one can interact with others that visit the space with you. Using a flat screen, such as a web browser on a computer or phone, one can navigate a 3D model as an avatar or fly through a space in a free camera mode. Though if one has a supported VR headset, they can navigate the space in 3D. The link to this space is provided in the description so you can explore it as you see fit. You are watching a video recording of walking around this space on my computer. It should be noted that the size of the PLY Gaussian Splat uploads to the site are, at the time of this video, limited to 50 megabytes. For this reason, I used a web-based Gaussian Splat editor named SuperSplat to crop out content far from the trail, and I compressed the PLY file to remove the spherical harmonic data. This limits the visual quality of the scene, but still provides an immersive experience. This park is a really large physical space for a Gaussian Splat. In fact, it's larger than Arrival Space planned for, and you can see I'll actually fall through the ground like in a video game. I reported this issue to the Arrival Space team, and they said they would extend the ground area in the next update. I previously mentioned that in addition to walking around like an avatar in Arrival Space, one can enter a free camera mode and fly around. This can be done by pressing the F key while viewing the space with a computer. Here we will fly around while I talk more about Gaussian splatting. Gaussian splatting was introduced in the summer of 2023 in a paper by the INRIA group titled 3D Gaussian Splatting for Real-Time Radiance Field Rendering. They provided software to process image sequences into essentially colorized blobs in space that can be rendered in real time into impressive-looking scenes. I used their software to process my photos. It should be noted that the INRIA software can be challenging to set up on a computer and requires above-average computer hardware. Fortunately, in the last year, multiple other software packages have been created to build Gaussian splat models either on the web or on a computer. Some notable examples are Polycam, PostShot, Luma AI Interactive Scenes, as well as multiple others. Before using the INRIA software to create the .ply Gaussian splat model, I pre-processed the photos to align them using Agisoft Metashape photogrammetry software. This past summer, Metashape added the capability to export aligned cameras in ColMap format. That's the format used by INRIA software. In fact, ColMap is the first step utilized by the INRIA software. This is a great new Metashape feature because the photo alignment quality offered by Metashape is, in my experience, far superior to that provided by ColMap. As we continue to fly around the scene, let's summarize the demonstration that has been provided in this video for creating an interactive scene. This involves 3 steps. First, one must capture photos or videos of an environment from many, if not all, perspectives. Second, those photos need to be processed into a Gaussian splat model using either web or computer-based software. Finally, the resulting .ply file containing that Gaussian splat model is uploaded to Arrival Space. If needed, the space can be cropped using SuperSplat to limit the size of the file. While I haven't demonstrated each of these steps, a quick search on YouTube would certainly find videos detailing how to accomplish each one. Links have been provided in the description to the imagery used in this video, the resulting Gaussian splat model, and the Arrival Space link for you to visit the park. Be sure to try that in VR and a headset. Thanks for watching.